4 of the question, the part 4 of problem solving. So the same question, but part 4 here, it refers to dry saturated vapor delivered to the compressor and the liquid after condensations undercooled by 10 K. So this part 4 here, or part D here, it includes undercooling. So what I have said just now, remember something I have said wrongly when you refer to the previous section, that COPHP is actually 1 plus COPR. Okay, that's my mistake. Okay, and sorry for that. COPHP is equals to 1 plus COPR. If let's say you want to find COPHP. So this would be DS diagram. You include undercooling. Okay, when undercool is included. Okay, so that is 3 to 3 prime. So basically, if let's say, for example, when you refer to the question, they say after, okay, condensation, the liquid is being undercooled here by 10 K. So usually that would be the exit of the condenser. Usually this would be the exit of the condenser. Since there is an undercool or subcool, not intercooler, subcool or undercool, so you have a state point 3 prime here. But in actual practice, your state point 3 prime is sitting on the saturated liquid line. Your state point 3 prime should be sitting on the condenser pressure line. But for simplicity, okay, most of the references, they have considered that 3 prime will be sitting on the saturated liquid line. Then after that, it will undergo irreversible expansion in the throttling or the expansion valve. So how to find state point 3 prime here? So let's say, for example, the temperature which we used to have at pressure 12.37 bar was 32. Is 32 degrees C. Is 32 degrees C. So when it is undercooled by 10 Kelvin, so you take 32 minus this 10 here. If let's say it's undercooled by 5 K, then you need to take the temperature here 32 minus 5 K. Okay, since this is 10 K, so you have 32 minus 10 K. So the temperature here would be 22 degrees Celsius. So when you refer to your property table, you should be referring to the 22 degrees C. 22 degrees C. Okay, so same thing, what we have done, state point 1 dry saturated. We just take whatever we have from the previous slide, 1420 and 5.623. Dry saturated at 1.902 bar. Then state point 2, which is superheated at 12.37 bar. Now you don't have to recalculate this because we have already done. You just extract the values of what we have got earlier. Okay, of what we have got earlier for the H2. Then the H3 would be the HF, okay, at that, and S3 would be SF at that pressure, that is 12.37 bar. By now, you should understand. Then when it goes up to state point 3 prime, that is what it is, the most important thing here. That is state point 3 prime, saturated liquid refrigerant, because we assume that state point 3 prime is sitting on the saturated liquid line after undercooling. So what we do is we take the temperature T3, 305 minus 10. Okay, then minus 273, you get 22. Or you can straight away directly take 32 minus 10, you still get 22. Okay, so based on this temperature T3 prime, Okay, look for HF at this temperature. That would be your H3 prime. So that is 284.6 kilojoules per kg. So why this is important? Because you need your H4. So to find your H4, you need to have your H3, not your point H3. Okay. So that at 22, HF at 22 degrees C, you will have 284.6 kilojoules per kg. Then state point 4, as we know, it should be H3 prime, sorry. It should be H3 prime here. So that is 284.6 kilojoules per kg. So this formula here I've shown you just to remind us, okay? Because just now I have said something wrong. COP-HP is equals to 1 plus COPR, okay? So I've listed down all the enthalpies. Some of them are from the previous section. Then the only thing is your H3 prime now. Here is 284.6. Instead of using H3, we use this one, H3 prime. Okay, so your QH, if you want to take, should be H2 minus H3 prime, not H2 minus H3. Should be H2 minus H3 prime if you want to find your QR. That is the heat rejection. So H3 prime is equal to H4. So you have this. So what you need to do is work out your RE, okay? And then work out your work in again. Remember this H4 here, that will change. Okay, if you take this, instead of this, the value here will be different. So that will be your work in, and this will be your COPR, 4.08. So if you want to find your COP-HP, you can take 1 plus CO. So your COP-HP should be 5.08, like that. Okay, that's for the refrigeration cycle. Okay, so these are all the simple ideal vapor compression cycles. So the cascading system and the multi-stage system will be on the later part. And thank you and stay safe.